Good afternoon, everyone. I was originally going to do a video explaining the solution to the very interesting polynomial problem that I gave you yesterday. However, because I also wanted to do continue with the logic series, the other explanation, there's a lot to unpack in the polynomial. So after thinking about it, I don't think it would be a good idea. I didn't think it would be a good idea to mix two very different topics in the same video. I don't think that's productive at all. So I will give you the solution to the polynomial question tomorrow. I already saw some incorrect responses, though. I don't want to say which one, obviously, are incorrect because I want to wait until tomorrow so that we can go over it in rigorous detail. But today I will, and plus I'm kind of short on time today, so I will have time to do this one to describe functions in a proper way, the proper way you should understand functions. But then I have a lot of things to do. I wanted to take a walk around the trails today before it starts raining again. And I used to back a few years ago. I was blessed because I was able to go horseback riding, but unfortunately I injured my back a little bit. Not nothing to do with the horse. I had some medical issue, and so unfortunately, but at least I could still take walks and be around nature and all of that. So, but anyway, what we got to talk about functions, which is really the bedrock of mathematics. It's really as simple as it gets in a way, because when you're dealing with the basics, you should have first foundations. Foundations should always be clear and straightforward, much like the principles that have guided true understanding through the ages. But when we deal with sets in all their simplicity, they hold the key to nearly everything we do in mathematics. And that's because, quite frankly, anything more complicated would just be an exercise in intellectual indulgence. And we have a lot of nonsense going on around in our schools these days. And probably if you are watching this video, unless you are a math major, perhaps, and even in that case, sometimes I've had math majors tell me on this channel that not even you have heard until graduate school some of the things we've been doing in this video series on logic, which says a lot about the current state of our educational system in America. But that's why I'm going to make a bold prediction and say that probably if you are watching this video and you are in high school, the definition that, or even an undergrad in college, but maybe you're not a math major, but really the definition that they've given to you is probably very sloppy. You probably have no real idea of what a function actually is. The most some of you probably have heard is that I've heard something like sometimes they say it's like a machine, right? Which is okay for the I've used that analogy myself, but it's not really proper, and it's not something that should be indulged on if you really want to get deeper into what it is. Now, because functions really are where the real work begins, because they're everywhere. And although thankfully they're everywhere, unlike some of the other jargon we constantly hear that's sort of in our face these days. But you've encountered them at every stage of your education, whether you've liked it or not. Hopefully you went to a decent school. But I know, for example, if you remember from elementary school, when you learned to calculate areas, nothing too grand, but that was in a roundabout way, you were already being exposed to functions. Then you had middle school, where you were forced to grapple with equations and functions. And don't think I've forgotten high school, of course, when you were probably drowned in some Common Core algebra nonsense, pre-calc and calculus. And the more you study math, though, the more functions you encounter constantly, relentlessly. And they're not to be ignored. So functions are a big deal. We've already touched on the static, on the almost basic pedestrian properties of sets. But once we start applying functions to those sets, that's where things actually start to get very interesting. And it's when the real work starts. And everything you've been spoon fed up until now begins to take on a deeper, more complicated meaning. But don't worry, we'll get there. Just be patient, because I'm going to go through first. The definitions you will see first are probably the ones that your four teachers gave you, perhaps. But then we will gradually give you more definitions as your brain will gradually expand, hopefully, in this video. So the first definition to look at is as follows. All right, so hopefully you could see the definition on the board. And I want you to take a moment to pause the video, read the definition, pause the video, see what you can see here. and then we're going to talk about it. All right, did you pause the video? So, intuitively, you can think of the domain as the set of inputs of f, and that's how they teach it in many schools, by the way, and the range as the outputs of f. And the codomain, you can think of it as a possibly larger set in which all the outputs live. Now, I'm being hopeful that you've even heard the word codomain, because in fact, in many textbooks, modern textbooks, and I challenge you, let me know in the comment section if you are an undergraduate student or even a high school student. Look at the index of your math textbook and let me know if your particular math textbook mentions the codomain. Because I can tell you right now, the book that I was referring to the other day and yesterday, where was it? This atrocity, not only do they not mention codomain anywhere, but I'm going to quote to you the definition of domain that they give, the domain of a function. The set A is the domain or set of inputs of the function f, and the set B contains the range or set of outputs. I mean, this is ridiculous. This is ridiculous. A student who is reading this has no idea where this comes from. This is what we call poppycock. But anyway, I don't want to get into that discussion now. I'm curious because a lot of books don't, like I said, a lot of books don't even mention the codomain these days. And when you were young or younger, depending on how old you are watching this, the domain and the codomain were usually the set of all real numbers. However, the range tends to vary a lot. And the range consists only of the elements in the codomain which get hit. That is, that y is in the range if there is an x in the domain that maps to it. We call it mapping. So, for example, f of x equals 2x. Well, in that case, the range is all the real numbers. But if I gave you f of x equals x squared, you cannot say all real numbers, right? You have to say the set of non-negative real numbers, because there's no such thing as a square that is negative, right? In the real number, in the set of real numbers. So in the case of x squared, it would be a semi-closed interval. It would go from 0 to infinity. By the way, this A with the arrow next to the B, that's read as F from A to B. Now, I want to tell you something before I show you any diagrams. A recurring theme. When we are discussing functions, we have two ideas here: existence and uniqueness. And that's going to come up repeatedly. In fact, we already begin that here with this definition. We've defined a function in this way. What this means in reality is that f of x has to exist, meaning it must be equal to some b in the b would be an element in the set B. And it must be unique. It must be equal to only one element in B. So perhaps this will, if I show you a diagram, then perhaps you'll be able to see it more intuitively. All right, so hopefully you can see on the board, this represents a function here. Now, a function's domain and codomain can really be any set you want. And so I gave it's a rather silly example, obviously, but just to make the point. You have in the domain 1b, and by the way, that squiggly line, it's just a bad drawing. That's supposed to represent a flying bird of some kind. And then you have a triangle. And then you have your codomain. And notice that in the codomain, you have a happy face, you have a heart, and again, that squiggly, that the bird, the flying object there. But notice that at no point was the heart hit. At no point. And so we say because of that the heart is not in the range. An analogy I like to think about when I'm teaching this is the other day I thought about this. I was at shooting practice. I love going to learn to perfect my shooting skills. And I was at the range. I have a very old style 1950s revolver, what they used to call a police revolver. Beautiful, beautiful piece of history, and it works beautifully. I'm a big fan of revolvers. They're easier to, for some reason, for me to manage. And you don't. I mean, I know the automatics, the semi-automatics. Also, they're much. The precision is much faster. But somehow there's nothing like just unloading, putting in that bullet in there. It just the feel is different. I like the old school, and I make no apologies for that. But anyway, so you could think of it as a target in a shooting range. The target has a potential. You have potential spots on the target, and you may miss your target. Right? I'm getting a lot better though. So if you think of the codomain here as your target, well, there we go. I missed the heart, right? But all of those that is in the possible range. So hopefully one day I'm getting better and better though. In fact, my instructor said, and I quote, this is not me. He said, "I can't believe you've only been with us 48 hours, total of 48 hours coming to lessons, and you're already almost becoming like I've known people," he said, "who come here like months, and they take months and months and months to perfect their and even then, a lot of them they have everybody has different skills, and so they get very nervous when they're handling a weapon. You should always, of course, be careful when handling weapons. That goes without saying. But some people overthink certain things, and it's amazing what you learn from other people as well. People have been shooting weapons for many years. Things that you overlook. So, but anyway, now very important. Going back to the idea of existence and uniqueness, we have to be able to identify when a diagram fails either of those. So, for example, if you have a look at the following, all right, so here you see an example where it fails existence, right? Uh, Now, it is perfectly okay if you had, let's say, two arrows that pointed at the same dot when you had the codomain, or zero arrows, or more than two arrows. But for the domain, the rules are rigid. One and only one line must emanate from each dot. So this would not be a function, for example. One of them is being sent to nowhere, right? You could think of similar language, perhaps, in the real world or the non-math world. Let's say, if you were to dial someone's telephone number, but the call goes nowhere, well, you would say your phone is not functioning. Or if you dialed a single phone number, but half the time the call goes to someone, Mike, and the other time the call goes to some random lady in Oklahoma, well, then you would again say that your phone is not functioning. We get that sometimes even from people. You talk to them and their thoughts go nowhere. They are not functioning people. There are students like that. You talk to them, you ask them what we're doing, they don't even know what page we're on. I had a student the other day. We were going through an assignment and we had been already like after about 20 minutes. What page are we on? Think about that. Very scary times. So, if something is properly functioning, it always responds to an action with a single anticipated reaction. So, if we go through the themes of that you might have learned in school, we've also talked about something called the vertical line test. So here's an example where you could use the vertical line test that you were probably taught that in high school. And we use it to check whether a graph corresponds to a function. So you could see here, right? If you draw vertical lines through these things, through these points, then we are in the presence of a function. It says that if the vertical line test, for those of you who don't know what it is, it says that if for every vertical line hits the graph in one existence and only one unique spot, then the graph is a function. However, let's say you had a circle, right? If you do the circle, if you were to draw a vertical line here through here, well, it doesn't pass, right? Notice that it hits twice. Now, does the vertical line test, does it ever fail? In other words, could f be a function and yet have a graph which fails the vertical line test? Well, the answer to that question actually, uh, it really comes down to what you define a graph to be. We've said many times that the definitions are very important in math. So if you're graphing a function on the xy plane, if it means that it is a function from R to R, and the x-axis, of course, is the domain, then the vertical line test would never fail, will never fail. But if you don't insist on this, then the vertical line test could actually fail. Because I want you to take a moment to try and think of an example, and then check out the one that I'm going to present to you soon, and tell me what you think. All right, so notice here where you would have a situation where you fail, the vertical line test fails. Here you have the codomain is, we have a Cartesian product, R cross R, and that is, it is the set of ordered pairs AB, and AB are elements of the real numbers. Now, let's look at other functions that you should know. The first one here is the floor function. Some people call it the greatest integer function, by the way. And you always round down. It's the rule behind it is that you have to round down a real number to either to the nearest integer that is less than. It has to be either less than or equal to it. But some people call that the greatest integer function, or the floor function as well. The other function that is familiar to you is here. This is the familiar x squared. Now notice here that you cannot plug anything else except the 1, 2, 3, 4, and 5, or 5, I should say, into g. Because if you do, let's say, g of -2, you're going to get a different value, of course, and then g of 6 as well. They don't mean anything here, because g is only defined to accept elements from its domain. Notice that the range here is 1, 4, 9, 16, 25. That's the range of g. All right. So the other function that you should have a look at, it looks sort of like, I don't think I typed it. I didn't type it. All right, one more for today, and then I will show you a more formal definition that I want you to keep in mind for our next video on logic. Let S be the set of containing all students in your logic class, and let G, evaluated at S, A, B, C, D, F. G of S equals the letter grade that student S received on their last homework assignment, or whatever you want, exam or whatever. So for this function, we better hope that the range does not equal the codomain. We would hope that everybody passed. But that's not always the case, certainly not in my class. We don't give away A's. You have to earn them. All right, one more definition, just I want you to keep in mind. We're going to get even deeper next week on this. We've only touched the tip of the iceberg here. All right, have a look at this definition and commit it to, have it in the back of your mind for our next video on this, probably next week. And Next week, we're going to talk about this. And then we also have to talk about injections, surjections, and bijections, which of course are not covered in the vast majority of high school textbooks these days, but they used to be. High school students who were on the, of course, not all high school students, but the high school students who were on the college prep track, they had to know that as recently as the 1990s. And I know that full well. And if it wasn't covered in your high school, you certainly covered it in your college algebra course. How many of you, if you're watching this, if you happen by chance to be, if there's any chance some of you are taking college algebra, if they have explained to you what an injection, injective function, surjective, and bijective functions are, I'd be curious to know. Have a great day, everyone. Stay safe as always. And hopefully tomorrow morning, Friday, I will post the solution to the polynomial. If this video was helpful to you, please, as I always ask you to please subscribe and continue to help us grow, continue to help us with the mission of this channel. Thank you all.